Hey everybody, welcome back to the channel, and today we're going to be talking about Pythagorean Theorem. Now we're going to get to the equation eventually here, but we're actually going to start the story with a picture, and it all starts with a triangle. So let's get started. Now I could just write down the equation, but I don't want to do that because I know, I know you've seen this equation before. You're going to say, I've seen this in a movie or in a video. I might not know what it is, but I've seen it before. This equation is really well known. It's like a famous equation, Pythagorean Theorem. And what I want to show you with this story, with this visual story, is kind of show you where this equation comes from and really understand why it is set up and written the way it is. And Pythagorean Theorem is a topic that's most commonly taught around 8th grade level. And like, I really wish so much growing up when I was learning about Pythagorean Theorem that someone had shown me this, because I'm one of those people where I grew up, I memorized the equation, I memorized the steps, I was spitting out answers, but I really wasn't understanding what I was doing or where everything came from. So in this video, what I'm just hoping to do is really convey to you maybe a better insight of where this formula actually comes from and why things are set up and put together the way they are. So let's just explore a little bit. So what you see in front of you is, obviously, it's an orange triangle, but it's a special type of triangle. It's a right triangle, right? We know that because of that little square in the corner. So a right triangle means that that angle has a measurement of 90 degrees. And I've gone ahead and I've labeled the three sides. So the two legs are A and B, and C is my hypotenuse. C is always going to be your hypotenuse will be your longest side. And what we're going to do right now is we're just going to do a little bit of geometrical exploration, right? So what I'm going to do is I'm going to take this triangle and drop in 3 more identical copies of this triangle. So let me move this aside. I've already cut them out. And I'm just going to drop in 3 more of these triangles, and I'm going to manipulate them here. Just going to twist them around and whatnot. Because they make something pretty cool when you put them all together. And they make this. It kind of looks like a square, but before we can say, hey, that's a square, we have to verify some things. But just taking a big step back and looking at it, I made 2 shapes here, right? I have this orange square-like shape, and also this negative space. This empty space is also what appears to be in the shape of a square. So to kind of verify that this outer shape is a square, we need to test a couple things, right? So a square is a quadrilateral. It has 4 sides. Has 4 sides, and all those side lengths are the same. They're the same measure, right? So let's just do a quick check. Obviously, we have 4 sides. In the corner, we have our right angle, and all 3 other corners, right? So all 4 corners in total, they are also right angles, so that's really cool. Now we just have to check the side lengths. So if we take a look, this side length right here, from here to here is A or B, right? And then this is also a length of A. So if we added A and B together, so A plus B, we would get this side length here on the bottom. And then if we look at this side is also composed of 2 sections. We have an A section here and a B section here. So if I added A and B together, so A and B together, I would get that vertical measurement there. And if I actually did that with the 2 other sides, I would also notice that this is just a combination of A plus B. This is A plus B. So all the side lengths have A plus B as their length. So they're all the same. Now, what I want to show you is that middle square. Now, this is also really interesting here. If I cut, I have actually a little cutout of that shape, and, I plop it in there. So that empty space, that negative space, has something really interesting too. If you look, this touches all the C's, all the hypotenuses, right? So this has a length of C. This side has a length of c. This side has a length of c. And this side has a length of c. All the sides have a length of c. So what I can actually do is take the area of that middle square. So I can say, well, area of a square is base times height, or length times width, right? So this is going to be c times c. And that gives me, let me move these things out just a little bit here. Let me write it out. C times c, that gives me c squared. All right, let me fix up my other square here. And get rid of this. Okay, so we know that this shape in the middle, this negative space, has an area of c squared. So we're going to remember that because that's important. Okay, now what we're going to do is just going to explore a little bit more. And what I'm going to do is this. I'm just going to manipulate some of these. Just going to twist them, right? Rotate them. And I notice that something else happens here. If I arrange them just right, I can get something here like this. And you might be able to kind of imagine that here's two other negative spaces, right? If you kind of put them all together, it might look like another square. So let's actually take a look at that. Here's this side right here, this negative space here. And we take a look at this negative space. So this is what we have. So it's basically, it's looking like we just made another square, right? It's like square inception, like squares within squares, right? So we have our two negative spaces. Now, if we look, now this is the cool part where things are starting to fall into place now. Okay, the yellow square, this top side has a width of a, right? Has a length of a. This also on the side has a length of a. So this in the middle, if we take the area of this square, this is a times a. So a times a gives me a squared. And then if I look at that blue square, this side has a length of b, and this side has a length of b. The area of this blue square is b squared. We might be kind of onto something here. So what this basically means, or what this can show, is if I take away these take these little orange pieces away, is that here's these three colors actually represent the negative spaces in that square that we made. So what this says is that basically these two areas here, the a squared and the b squared, if I add those together, I get c squared. So if I add these two negative spaces, a squared plus b squared, I get this is equal to c squared. This is Pythagorean Theorem. So it's like, this is one of these things where, let me put it back in perspective here. Let me move these out here. This is where this all comes back. Let me look. Let's go back. Where's my, okay, here it is. Let's look at my original triangle. It's the one I started off with. What Pythagorean Theorem says is that if I take this side, the a side, and I square it, and I take the b side, and I square that, I will get the c side squared. That's Pythagorean Theorem.